We're learning about the law of cosines, which is another law that gives a relationship between the sides and angles of any triangle, so not just right triangles. So let's start off by drawing a triangle similar to the one that we had yesterday, where if our angles are A, B, and C, the sides are across from the corresponding angle. The law of cosines tells us that to find any side, so this is little c, so it's the sides, this side squared is equal to your other two sides squared minus 2 times the other two sides again, and then cosine of the opposite angle. So this is if we're finding side C, this is cosine of big C. So this actually works for any side. So for example, if we were trying to find side A instead of side C, these two variables are now going to be our other two sides. So if we're trying to find A, this is now B squared and C squared minus 2, these two again, BC, and then cosine of the opposite angle. So what's opposite little a? It's big A. Right. And we can even do this again for our other side, which is B squared. So if we wanted to find B, now our other two sides are A and C minus 2, now this is AC, and now this is cosine of, we want the opposite angle. So opposite B is big B. So it works for any side. This is another way of using the law of cosines, which instead of trying to solve for a side, now we're trying to solve for an angle. So really, it's just this equation rearranged, solving for cosine C. So similar to this one, we can use this to solve for any angle as well. So if we're trying to find angle C, which is this one right here, A and B are the sides that are adjacent or next to the angle. And then C is the one that's opposite. And then this A and B are the same as these two right here. So again, we can write this equation for any angle. So let's say we're trying to find cosine of angle A. So this is my angle A. The first two variables are going to be the adjacent sides, so the ones right next to it. So this next to angle A is C and B. So we have C squared plus B squared. Doesn't matter the order, you could put B squared plus C squared. Minus the one across from angle A, which is A squared. And then 2 times, again, we're going to have the first two variables, so CB. Again, the order doesn't matter, so you could have BC here as well. Now let's do one more, where now we're going to try to find cosine of angle B. So here's angle B up here. The adjacent sides are now A and C. So that's the first two terms, A and C. Minus the one across from angle B, which is B. All over 2, and then again we're going to use our first two terms, AC, in the denominator. So this is going to work for any triangle. So let's take a look at triangle 1. Here is triangle ABC. We know that angle B is 35 degrees. A is 5, so this is the side. So here is big A, which is our angle. Little a is across from it, so this is supposed to be 5. Little c, which is a side across from angle C, must be 6. So this is a triangle where we have two sides and the included angle, so the one in between them. We can use law of cosines to solve for. We're trying to find little b, which is this one right here. So this is the one we're trying to find. What is b? So since we're finding our side, we're going to be using this equation right here, not this one. So our first equation, so we're solving for b. We're going to have b squared equals the other two sides. So the other two sides here are 6 and 5. minus 2 times my other two sides again, so 6, 5, and then cosine of the opposite angle, so the opposite angle to B is 35 degrees. And then to solve for B, all I have to do now to undo the squared is take the square root of both sides. So B is just the square root of this entire thing. So now I'm going to just go ahead and put this in my calculator. Make sure you're in degree mode. Okay, so square root, which is second, and the x squared button, square root. And we're going to put all of this inside of the square root. So 6 squared plus 5 squared minus 2, 6, 5, cosine of 35 degrees. So again, make sure this whole thing is underneath your square root. Press enter. We get B is equal to 3.44. Let's round 3 decimal because this is a side. Okay, so look at number 2. So for number 2, we're going to draw triangle A, B, and C. Little a, so the side across from angle A, is 10. Little b is 5. Little c is 6. So this is the case where we know all three sides. We're trying to find angle A. So angle A is right here. This is the one we're looking for. So because we're looking for an angle, now we're using the second formula, because that's the one where we're solving for an angle. So it's going to be cosine of, and we're solving for angle A. So cosine of A equals, we know we want the two adjacent sides first. So what's next to angle A is 6 and 5. So we have 6 squared plus 5 squared minus the opposite side squared. So minus 10 squared over 2 times, and we're going to have the 6 and the 5 again, the two adjacent sides. So let's simplify the top and the bottom. So 6 squared plus 5 squared minus 10 squared. This is negative 39 over 2 times 6 times 5, which is 60. Be careful you don't put this all in your calculator at once, or if you do, you need to put parentheses around the top and the bottom. So we have cosine of A is negative 39 over 60. And now we're trying to solve for A. So how do we undo the cosine? Inverse cosine. So we're going to do second cosine, negative 39 divided by 60. And that gives us our answer, because this is angle A, because it's big A, we're going to round to the nearest whole number, because this is degrees, so 131. Okay. A really quick important note. If you are to draw your acute and obtuse angles on a coordinate plane. So this is an acute angle, this is an obtuse angle. An acute angle ends up in quadrant 1. Obtuse angle ends up in quadrant 2. What we know about these quadrants using all students take classes is that sine is going to be positive for both. Right? Because sine is positive in the first and the second quadrant. But cosine is positive in quadrant 1 and negative in quadrant 2. Right? Because all students take classes in quadrant 2, cosine is negative. So what this tells us is that sine is the same for both acute and obtuse angles, but cosine is different. This is important because the law of sines cannot distinguish between acute and obtuse angles. It can't tell the difference. The law of cosines can. So if you're ever solving for an angle where your angle could be obtuse, do not use the law of sines. Okay, so if your angle could be obtuse in any way, don't use the law of sines. And remember that the largest angle in a triangle is always opposite the longest side. So let's take a look at example 3. So let's start off drawing our triangle again, ABC. We know side B is 15, C is 6, and angle A is 15. So what we don't know here, we're looking for angle B, angle C, and side A. So because we have two sides and the included angle, so notice we can't use law of sines here because we don't have a pair and we also don't have two angles. So there's no way we could solve this using law of sines. So we're going to solve this using law of cosines. So since we have these two sides, let's try to find side A using our law of cosine. So because it's a side, we're going to be using the first equation, a squared. So this is this equation right here. So a squared equals the other two sides minus 2 times the other two sides, and then cosine of the opposite angle. So opposite angle is angle A, 50 degrees. And to solve for A, we're just going to put all of this underneath the square root. Okay, so we're going to put this into our calculator. And this leaves us with A equals 12.054 since we're rounding it. And now we have a pair. We have big A and little a. So now we can use law of sines. So we know that angle A is 50 degrees. And now we know the side A is 12.054. So we can use law of sines because it's big A and little a. This is where what we just learned is important. So the other side that we're going to find now, because we're either going to find angle B or C, we want to pick the smaller one to start off with. Okay, the reason why is because the larger one could be an obtuse angle. So 15 and 6, we're going to use 6 because that one is smaller. So what we're looking for is angle C. So 6, because it's a side, is going to go on the bottom. We're looking for angle C. So now this is just law of sines. Multiply by 6 on both sides. And then to solve for sine, or to solve for C, we have to undo the sign. So this is just inverse sine of everything here. We're going to put this into our calculators. Second sine, 6 sine 50. Close your parentheses, divided by 12.054. And this gives us an angle of, because this is an angle, we know it's going to be a whole number, 22 degrees. That's our angle C. And now we actually have two angles. This is 22. So it's going to be really easy for us to find our last missing piece because angle B is just 180 degrees minus the other two angles. So 22 plus 50 is 72. And 180 degrees minus 72 gives us 108. So notice angle B is indeed obtuse, which is why we could not use the law of sines, because if we did law of sines, we would not have gotten this answer, because sine cannot tell between obtuse and acute angles. Okay, one last problem. For number 4, we are given 3 pieces of information. So we're going to use this to label our triangle. Side AB is 15, so this means AB, which is the side right here, is 15. BC is 32. AC is 24. We're trying to find the length of the median to the longest side. So the longest side is 32. So the median just means if we're splitting up the longest side, it's going to split it right down the middle. So let's label this. If this is splitting it right down the middle, that means these two are equal to each other. And so this is going to be 16. This is going to be another 16 because it's right down the middle. Now what we're trying to find is the length of the median. So let's just call this M for median. That's what we're looking for. To solve this problem, our first step here is we're going to use the big triangle, so the whole triangle, to find angle B. So we're trying to find this angle right here. Excuse me. So if we're trying to find this angle, we're going to use law of cosines. Cosine of B equals the adjacent sides. So if this is angle B, the next to it sides are 15 and 32. Minus the opposite side, which is 24. Divided by 2 times the first 2 sides we just wrote down. So this is, again, I'm going to first do the numerator, then the denominator. So the numerator gives me 673. The denominator gives me 960. And to solve for B, I'm going to be taking the inverse of this. Inverse cosine. So 673 divided by 960. We know that B is 45 degrees. We're rounding to the nearest whole number. So I know this is 45. So now my second step is I can use my small triangle to find M. So look, now I have this side, I know that this side is 16, and I know that this angle is 45. So what I'm going to use is the law of cosines to find M. So M squared equals, I'm using this small triangle right now. M squared equals the other 2 sides, so 15 and 16. Now I'm using the small triangle, so make sure you're using the side for the small triangle. Minus 2, 15, 16. Cosine of the angle, which is 45 degrees. And so we're just going to find the square root of this entire thing, put it into our calculators, and this is going to give us our answer. So 15 squared, square root of 15 squared plus 16 squared minus 2 times 15, 16. Cosine of 45 degrees. And this gives us a measure of 11.899. And that is the length of my median. That is my final answer.